Hello again. Welcome back to my channel. Thank you for watching my videos. Now I'm going to talk on IR spectra to use your uh, s- to solve the structure chemical formula. So before approaching your overall approach, you need to know some basics about the IR. So first of all, let's see if you have any molecule that has an oxygen, one oxygen, so you can look for three things. First of all, in the IR, it start from the 600 or like below and it finish at 4000 per centimeter. Okay, this is the IR scale. So if you have any molecule, suppose C6H12O, okay, C6H12O, this molecule. So first of all, you can easily calculate the soda number. So the number is 6 plus 1 minus 12 by 2, 7 minus 12 by 2 is 6. So you'll get soda number 1. I also, if you don't know what is soda number, just watch my previous video part 1. You will get the idea about the soda number. And in that video, I forgot to say, even if you have the carbonyl group like C double bond O, that also will be counted as a soda 1 because it has also double bond, carbon oxygen double bond. There I didn't mention that, I forgot to mention, but here just remember that if you have the carbonyl group, that is also soda number 1. Now, so I'm pretty much sure you already know the ketone, aldehyde, alcohol, those kind of things. So with the IR, normally we determine the functional group. So presence of functional group, what kind of functional group is there? So you know that this is if you have the both any carbonyl group and both hand is with the carbon substituted, then it is called ketone. This molecule is acetone, but you might have more of these like CH3, CH2, something like this. So it is a ketone. So both this carbon has both another two carbon. But if you have this similar molecule, but one hand with hydrogen only, that is aldehyde, okay? And definitely if you have any molecule have oxygen, OH, so this is called alcohol. So when you have a structure, given a structure, and you have only one oxygen, you will look for three things in the IR. Either it can be ketone or it can be aldehyde and it can be alcohol. How you will know which one is what? Okay, so the scale is suppose it is in 1500 and it is 1600 and it is 1700 and suppose it is 2000, and in IR scale the printout always make sometimes squeezed, but it follow the scale, it's fine. Okay, so 2000 and suppose it is a 3000 and this is 4000. So if your molecule has the alcohol OH, then one oxygen will be used. So in that case, you will see a broad peak from 4000 to 3000. Okay, so that broad peak, that is for OH peak, like alcohol peak. So if you see any broad peak around this 3000 to 4000, so or like 3500 to 3000, so you can say yes, it is alcohol. Okay, why alcohol is a broad peak? Because alcohol always can produce the in intramolecular or intermolecular hydrogen bonding. So since it can produce hydrogen bonding, and that's why it is stretching always show a broad peak. Okay, so but if you don't see any OH peak here in the IR, so immediately you can look for any peak around 1700, something like this. So normally 1700 to 1740. If you see something like this, so you can immediately consider you have a carbonyl group here. So this molecule should have a carbonyl definitely if you see any peak here. But don't be confused with the ketone and the aldehyde. because if you have the molecule aldehyde, still you will see the similar peak around 1700 to 1740. Along with, to be aldehyde, you need to have some other peak here. So if you don't have that peak but only this peak, then you can say it is a ketone. Okay, but if you have this peak along with a small peak around these two peak, one is 2720, another is 2820. So if you see these two peak along with this carbonyl peak, then you can clearly say, okay, combining these two, it will have, you can say you have an aldehyde peak. So aldehyde peak should be like C double bond OH. So this is an aldehyde. Okay, so if you have one oxygen, so you look for first alcohol in the broad band, no alcohol. If you don't see no alcohol, if you don't see these but only see these, then it is a ketone. If you see these and also two small band at 2720 and 2820, then you can easily say, okay, I have the aldehyde functional group. Okay, now let's see another molecule. If you have two oxygen in your molecule, so whenever you have two oxygen, first look for the carboxylic acid. So to be a carboxylic acid, what is the carboxylic acid looks like? C double bond OH. So it is the carboxylic acid functional group. So from the IR, you can only get the information about the functional group, nothing else. So what are the functional group present in the molecule? Then you can piece together, like you can put together all the pieces to get the final structure. So for the carboxylic acid, definitely you will see one carbonyl peak, because it has a carbonyl peak part, but along with that it has a hydroxyl. So normally if I expand the scale a little bit here, like 3000, and maybe here like 2000, and maybe here 2500. So for the carboxylic acid, you will always see like very weird shape, a broad peak from 2500 to 3000. So it's sometimes even it's like people say cow udder type peak, cow udder. So so broad peak along with this carbonyl, so you can easily say this is a carboxylic acid. Okay, so it also, if you have two oxygen, if it can also be ester. So what is the ester? So same C double bond OO CH3, okay, or R, alkyl group, say any alkyl group. So this is an ester group. So in case of ester, you will see this peak but no broad peak. So still for this, you can primarily assume that, okay, it might be the ester, because I have two oxygen and only one carbonyl peak, there is no significant peak for the carboxylic acid. It could be the ester, but in some cases it could be ketone along with an alcohol. Suppose you have a molecule, like this. So in this molecule you have one oxygen, two oxygen, but it is not ester. You have one carbonyl group, that peak is there, and one alcohol. So definitely you should have a broad peak here for the alcohol. So if you have like this, like ketone and alcohol, then you might think like that, not like this, not like ester. So if you have two oxygen in your molecule, it could be the carboxylic acid, it could be the ester based on the pattern, and it could be also the ketone and alcohol. So ketone and alcohol. But if you don't see any alcohol peak here, so in that case, that option will not be. But still, there could be another option. That could be a ketone and ether. So suppose you have a molecule like this. So this is ether. Ether doesn't have any specific peak around this area, so you will not see that, but ketone is there. So that in that case, if you have the ketone and ether, so in that case you need to rely on proton NMR and carbon NMR, but at least you will get some information for the carbonyl group. How? For the soda number, you will see 1, soda 1, so that should be the carbonyl group. And also there is no double bond, So in that case, then you can get an idea, okay, I have only one double bond and that is a ketone peak, so I have the ketone group, and the remaining things may be something else. So based on the proton and carbon NMR, we can finally determine, but at least you will get some idea from there. Okay, now if you have oxygen in your molecule but you don't see any carbonyl peak, okay, any alcohol peak, nothing for this area, okay, but you have the oxygen in your molecule. So in that case, what it could be, so if you don't see any peak in the air, but still you have the oxygen, so in that case you can think, okay, those oxygen can be ether oxygen. Okay, although for the ether there will be some fingerprint, this area is called fingerprint region, but this is very confusing. Sometimes one information match with another information, so sometimes I don't prefer to get the consideration the peak of this area, especially the ether. So you need to remember a lot of information, a lot of values, so don't need to, like, just try to remember the signature peaks where if you see, and you can immediately get it. But still, how you will know that? So if you have one oxygen in the molecule, suppose you have one oxygen in the molecule, so it could be any ether like this, or like more chain, whatever. Okay, so if you have two oxygen in the molecule, so it could be like this, a ring. So in that case, calculate the soda number. Definitely you will get soda 1 for this ring, and 2 oxygen is there. And not only that, sometimes it can be also like this. 2 oxygen is there. Okay, sometimes also like this. So different way. So those are kind of ether. So in the air, you will not see the ether. Okay. So now with the oxygen containing molecule is done, the ketone, aldehyde, is carboxylic acid, ester, alcohol. Okay. Now, if you have the nitrogen in your molecule, suppose you have the nitrogen. Okay. So that nitrogen can be 3 different things. One is primary amine, one is secondary amine, and one is tertiary amine, like R. Okay, suppose R. So this is a primary amine because you have 2 hydrogen, and this is a secondary amine, you have 1 hydrogen attached here, and this is tertiary amine or 3 degree amine, there is no hydrogen attached in the nitrogen. So we can say 1 degree secondary, or 2 degree and 3 degree amine. Okay, so for the 1 degree amine, you will always see above 3000, you will always see 2 narrow band for the primary amine. Remember that primary amine has 2 hydrogen, NH and H, so that will give one stretching, that will give another stretching. That's why it is 2. So you will see 2 band. That should be like 3000, 3300 to 3600. So if you see something like this, so you can say, okay, my nitrogen in this molecule is as a primary amine, that's why I'm seeing this band. Okay, but if your nitrogen is in the secondary condition, like 2 degree amine, so you will, since 1 hydrogen, so remember that 1 hydrogen 1 band in the same region, so it will be secondary amine. Okay, but if you have the nitrogen and you don't see either double band or the single band in this region, there is no band, so you can say, okay, my nitrogen is as a tertiary amine, like 3 degree amine. So for the amine case, remember for 2 degree you will see 2 band, for 1 degree or primary amine, 2 hydrogen is there, so 2 band. Secondary or 1 hydrogen with the amine, so you will see 1 band, or nitrogen, nothing, no hydrogen, so no band. So those are for the amine. Okay, now how about if you have the alkyne group, alkyne, okay? So, uh, oh, since I was talking about the nitrogen, there is another option for the nitrogen, that is nitrile group, C triple bond N, okay? So if you have the nitrile, this nitrogen is a no hydrogen with that, okay? So that is also, we cannot say it is tertiary amine, it is a nitrile group. So to sort out or to finalize your nitrogen as a tertiary amine or nitrile, you can determine one thing. So you'll see one band here at 2100 to 2200. So that band is for the nitrile. Okay, so carbon nitrogen triple bond. So if you see this band is there, in that case you cannot say this molecule is tertiary amine. No, that will be a nitrile. So in case of nitrogen, you will look for four different compounds. First of all, primary amine, so two band. If it is there, yes. If it is not, no. Secondary amine, you will see one band here, like above 3300 to 3600 here. So if you see that, yes, secondary. If you don't see that, no, secondary. And then look for the nitrile first. If you see any band here like 2100 to 2200, so you can say, okay, if you have this, so okay, that nitrogen has a nitrile group, okay. If it is not there, then you can say, okay, since nitrile is not there and no band is there, so my nitrogen will be tertiary amine or 3-degree amine. I hope it is clear to you, okay. Now let's see, since I'm talking about the nitrile group, so now carbon-carbon triple bond like alkyne. That alkyne also will give you the similar band near that area, like 2150 to 22 or 2300. The similar, so you can say this is alkyne group. Alkyne carbon-carbon triple bond peak. So carbon-carbon triple bond peak could be in the same region like alkyne and also the nitrile, okay. But if you have the nitrogen in your molecule and you see this peak there, so probably you can, and no amine peak there, so you can determine like maybe it is my nitrile group, not alkyne, okay. And also soda number will give you the some information, and also the carbon NMR and proton NMR, those will give you some information. So preliminarily you can think like maybe that is a nitrile group. But if there is no nitrogen but still you see this peak there, then you can, and soda number 2, if you get the soda number 2, there is a triple bond, and this is the presence of this triple bond. Now alkyne can be terminal alkyne or the internal alkyne. So what is a terminal alkyne? Suppose you have another carbon and you have this hydrogen here and this, okay. Now if you have one hydrogen with the one of the triple bonded carbon, so this is called terminal alkyne. So if you have the terminal alkyne CH, so along with this peak, you will get definitely one sharp band around 3100 to 3200. So if you see these together, this one and this one, then you can say your alkyne is a terminal alkyne. Like one carbon with the triple bond has the hydrogen at the end, okay. But if you don't see any peak here but only this, then you can say, okay, I have the alkyne, it's fine with the soda number 2 and also this peak, there is no nitrogen, so it could be triple bond definitely, but it could be like internal alkyne, so the triple bond is in the middle of the structure, so that could be like this. So I hope you understand the 3 bonded things like alkyne and the nitrile. Now if you have the alkene carbon-carbon double bond, so in that case you'll see one peak around 1500 to 1600, so that peak is for carbon-carbon double bond, okay. And so this is only carbon-carbon double bond. But if you have a benzene ring, So it has double bond and it is an aromatic ring. So in that case, you will look for two different peak, okay, for the benzene peak. One is like around 1600 and another is, if it is 1400, so another is like 1450. So these both together, actually it will be like in the IR, you know, like this will be like this something like this. So if you see these two peak together, then you can say, okay, this is the aromatic ring, so I have the benzene ring. Okay, so sometimes you might have double bond and alcohol together. So in that case, suppose you have a molecule like this. So you have a double bond and one alcohol. So in that case, you will see one peak around here like 1600, not 1600 actually. So it should be like in between the 15 to 1600, and one like this, like broad peak. So you can say, okay, I have the alkene and the alcohol peak together. So I think now it will give you some sense or information about the IR, like how you are going to gather the information for the functional groups. So all the functional groups, you need to know the functional groups. That's how you can get the pieces for the structure to determine. So in short, I just want to review some functional groups. So if you have the OH, this is the alcohol. If you have this carbonyl group, that carbonyl, if you have the carbonyl R and R, so it will be the ketone, okay, ketone. And if you have the carbonyl with the hydrogen, so it will be aldehyde, okay. And if you have carbonyl group with OH, that will be carboxylic acid or organic acid. If you have one R here, alkyl group, then it will be ester. So it will be ester. Okay. And if you have NH2, or like you can write like this way also, the primary amine, if you have one nitrogen with the hydrogen and one R, so it will be secondary amine. This is primary amine, secondary amine. And if you have nitrogen R and R, so you can say it is tertiary amine, or your nitrogen also can be this cyanide group or nitrile group. So nitrogen containing compound could be like these four types, okay. And you also have alkyne group. So that alkyne group can be internal alkyne, or your alkyne group can be terminal alkyne. You also have carbon-carbon double bond, so it also can be internal and inside or outside, whatever. So a double bond means the alkene. So you have the alkene. So peak should be like around 1500 to 1600. So if you see any peak, one band, so double bond. But if you have aromatic ring, so you'll see this is aromatic or benzene ring. So you'll see one around 1550, another is around 1600. So these molecules will, this band will show you the aromatic ring. So there are many other information can be found by IR, but these are the common basic information you need to determine the structure. In some cases, you might need the IR of the anhydride. So if you have any molecule like C double bond O, and there is another like these CH2, something like this. So this is anhydride bond. So in that case, anhydride bond, you will see two carbonyl peak. One is around 1750, another will be like around 1900 or 1880. So two band there. So this is very rare, but still just you can remember one is around 1700 to 1750, another should be 1850 to 1900. So two band actually in the IR. So you'll see one band here and another band here. So it will be like around 1700 and it will be like around 1900. So if you see two band there, so you can say it is an anhydride carbonyl group. Okay. So today till this, that's it for the IR, and next lecture will be on the carbon NMR and proton NMR. And once we know the carbon and proton NMR and little bit about the mass, so then we will go for the structure elucidation. So till now, stay fine and keep watching my video, and please subscribe my channel if you didn't subscribe yet, and that's how I'll get more inspiration to do more video. So if you watch my video and if you ask me the question, then I will get more inspiration to teach you.